Let us continue our topic. This is the chapter 3, linear pair of equations in two variables. We have seen how to solve the equations graphically. We have seen few questions. Now we are continuing further. Today's topic is to find whether the lines are intersecting, coincident, and are parallel lines. This topic we have already covered by graph. Now we are going to see without doing the graph, and also we can decide about the equations, whether the equations are consistent or inconsistent. So there are three conditions, and these conditions are of comparing ratios. Now if let us take the two equations. The two equations are a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. Let us take these two linear equations. Okay, now in two variables. So the condition number first. Now we have to compare the ratios. Now if, listen properly and see, if a1 upon a2 is not equal to b1 upon b2, then the lines are intersecting. Lines are intersecting. This is very important. If a1 upon a2 is not equal to b1 upon 2, then the lines are intersecting, comma, they have unique solution. Unique solution, second point, means one solution if they are intersecting, and equations are consistent. So these three things you have to remember. Condition is that the ratios mean a1 upon a2 should not be equal to b1 upon b2. I will show you with the example. So this is the condition number 1. Now let us take the condition number 2. If a1 upon a2 is equal to b1 upon b2 and also equal to c1 upon c2. You see that all the three ratios are equal here. If all the three ratios you have to compare, and if they are equal in every respect, symbolically and ratio wise also, then the lines are coincident. Lines are coincident. Very important. Mean they will represent, both the equation will represent one line. Infinitely many solutions. So these equations will have infinitely many solutions and consistent. One more point we can add, equations are consistent and dependent. These things you have to remember. Remember this. Condition is all the three ratios should be equal. The lines will be coincident, that is representing one line. Infinitely many solutions, and equations are consistent and dependent. Now condition number 3, this is the last condition. If A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2. So here the third ratio is not equal. First two ratios are equal and third ratio is not equal to them. Then guess now. What will be the lines now? Tell me. Think in your mind. Try to find the answer on your own. Then we have already done this in our graph. Then the lines are, yes, right. If you thought parallel, then you are right. Lines are parallel. Comma. These lines are parallel. They will not intersect each other. So therefore there is no solution. They will not have any solution regarding the solution. And these lines are inconsistent. Equations are inconsistent. These things are very important. Now in next my video, and coming this video only, I am going to show you with the help of examples. So let us recall. If first two ratios are not equal, this is very important, then lines will be intersecting. They will be having one and only one solution, that is unique solution, and the equation will be consistent. And if all the three ratios are equal, then the lines, both the lines will be single line, that is coincident. They are coinciding with each other. Infinitely many solutions, and the equations are consistent and dependent. And if first two ratios are equal but the third ratio is not equal to them, then the lines will be parallel, and lines are parallel mean they do not intersect. That means they do not have any solution, therefore they are inconsistent. Let us take the example. So heading will be same. We will find whether equations or whether the lines intersect, are coincident, are parallel, and solution. And also we decide consistent or inconsistent. So everything I am showing you in one example only. So this is a question, and now first question I am taking 5x minus 4y plus 8 is equal to 0, comma 7x plus 6y minus 9 is equal to 0. Now these are the two equations. Solution. Let us take the equations first. 5x minus 4y plus 8 is equal to 0. This is the equation number 1. Here a1 is equal to 5, b1 is equal to minus 4, and c1 is equal to 8. And take second equation now. 7x plus 6y minus 9 is equal to 0. Now here a1 is equal to 7, b1 is equal to 6, and c1 is equal to minus 9. Now let us find here. Now a1 upon a2 find separately. In the first example I am showing you separately, then we will take directly. So a1 upon a2, what is a1 value? 5. And what is a2 value? 1 minute, just really let me do the correction. In second equation, a2 is 7, b2 is 6, and c2 is minus 9. So this is the correction here. A2 is 7, B2 is 6, and C2 is minus 9. So what is A2 value? 7. Now B1 upon B2, let us find B1. B1 value is minus 4. And B2 value is 6. So if table goes, if we can simplify, if we can reduce the fraction, you can here. See here, 2 table goes, so it will be minus 2 upon 2, 3 just 6. And C1 upon C2 is equal to 8 upon minus 9. Table is not going, we can write minus in the middle, 8 upon 9. So here you find that A1 upon A2 is 5 upon 7, B1 upon B2 is minus 2 upon 3, and C1 upon C2 is minus 8 upon 9. So actually there is no need to find out this one, when here only directly we can compare. So here A1 upon A2 is not equal to B1 upon B2. Hence, the lines intersect in one point, because this is the first condition, comma, they have unique solution, and equations are consistent. So this is your first example. Now second example, 9x plus 3y plus 12 is equal to 0. This is the equation number 1. Here A1 is equal to 9, B1 is equal to 3, C1 is equal to 12. Equation number 2, 18x plus 6y plus 24 is equal to 0. So A2 is equal to 18, B2 is equal to 6, C2 is equal to 24. First we'll write the question here. This is the question here and this is the solution. So now we have found all this one. Again you see 9x plus 3y plus 12 is equal to 0. This is the equation number 1. A1 is 9, B1 is 3 and C1 is 12. Now this is the equation number 2, that is 18x plus 6y plus 24 is equal to 0. Here A2 is 18, B2 is 6 and C2 is 24. Now find out all the three ratios. A1 upon A2 is equal to 9 upon 18. Table goes, 9 table goes. 1 upon 2, comma, B1 upon B2 is equal to 3 upon 6. Again 3 table goes. That will be 1 upon 2. Then C1 upon C2. C1 upon C2 is 12 upon 24. That is 1 upon 2. Now you see that all are equal. Every ratio is 1 upon 2. Hence, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. All the three ratios are equal. Hence, the lines are coincident. And they have infinitely many solutions. This is the condition number 2. Infinitely many solutions. Equations are consistent but dependent. Now example number 3.